Okay, let's say that you're the coronavirus. Let's say that you are the coronavirus, and you just entered the first person of the United States. Someone just got back from China or Italy or whatever, and let's say you got one person infected. You got one person infected, and let me draw a picture of that. This is you. This is you. You're going around infecting people. You got one person infected, and that person goes hang out with his two other friends that he has, and then you got three people infected. And let's say those people go out and they go hang out with their friends, and now you got 9 people infected. And let's say those people go out and that friend, their friends, or whatever, and then you got 27 people infected. And this just goes on and on and on as days goes by. Like this is day 1, this is day 2, this is day 3, this is day 4. And let's say like you want to know, like you're doing a pretty good job out there. Like you kind of like these people, they're not washing their hands, they're touching their face all the time. They just keep buying toilet paper for some reason, and you're like, this is easy. This is easy. And you want to see the total amount of people you're going to have infected. So you want to add up all of these. And you're going to keep on going. So you want to add up all of these. And you're a coronavirus, and you've taken BC. So you're like, huh, like this kind of looks familiar. This looks like geometric series here. So let's say we write it out in this form. And you want to basically find a series, and you want to see if you can add it all up. Or even if you can't add it all, like maybe you diverge, maybe you're just gonna keep getting bigger and bigger until who knows what happens. So basically, we can kind of see that as a geometric series because it's increasing by a rate every time. And an easy way to do this, to find what the rate is we just divide one term by the other. So if we divide 3 by 1, we get 3. If we divide 9 by 3, we get 3. If we divide 27 by 9, we get 3 again. So you're kind of tripling every time people go out. Your infection is quadrupling your rate. So we know your rate is 3. And then it'll be 3 times n. And you're like, wow, that's not bad. That's a pretty good rate. So and what do we know about rates? One thing we know about rates is that if the absolute value of the rate is greater than 1, then your series is gonna diverge. So you're going to diverge. And so that basically means that we can't find a sum. Like it's kind of like you'll just keep infecting people until it just keep getting bigger and bigger, going up to infinity. So you're like, oh wow, you're pretty satisfied with that. That's not bad. But let's say like a few weeks in, things start changing. Let's say a few weeks in, something happens. Let's say the government's like, yo, this is getting kind of bad out there. Like we're gonna shut everything down. People start washing their hands. They stop hoarding toilet paper. Let's say that people are just keeping their social distance, 10 feet apart everywhere. And let's say this happened on like some day and you have like 81 infections. Let's say you have 81 infections, but then oh shoot, like they're starting to cure people. People are getting released from the hospitals. They got a vaccine now. Like everything's like kind of coming together. So let's say now that and then you see that 81. The next day is 81 divided by 3. And the next day is 81 divided by 9. The next day is 81 divided by 27. And you're like, oh shoot, it's getting kind of bad out there. It's getting smaller and smaller. And you're sorry, but you still want to see how many people, like your end numbers, you want to see that good money. You want to see your high score. And so you want to see how many people have told you infected. And you start to notice, oh, this is starting to look like another geometric series over here. So let's do the same thing. Let's take it to infinity. Because we know it's going to get smaller and smaller, but like, who knows when it's going to go away. So let's take it to infinity, and let's try to find the rate here. So basically, let's divide our second term by first term, divide our third term by second term, and see if we can find like a common pattern that's coming through. All right, so 81 over 3, divided by 81 is just times the reciprocal, so that's 1 over 3, and the next one, 81 over 9 times 3 over 81 equals 1 over 3. So we can kind of see that we're kind of like multiplying by 1 over 3 each time. And so you know the form of geometric series is basically A and R n. So the initial term is 81 times our rate, which is 1 over 3 to the nth power. And you're like, this is not good. Like our numbers are kind of dropping here. Like this is a geometric series, and we can kind of see since our 1 over 3 is less than 1, that we know this series converges. And if we know a series converges, then we can use a simple formula to kind of find what number it converges to. And that simple formula is a over 1 minus r. And so we have our a here, and we have our r. So we go ahead and plug all these things in. We might just find a number. So a is 81, and 1 minus r is 1/3. So we got 81 minus 2/3 equals 81 times 3 over 2. That equals 81, or goes out the calculator, not a sponsor, times 3 by 2. You got 121.5. Those are pretty weak numbers, not gonna lie. Like coronavirus, you gotta step your game up, bro. I think we did a pretty good job of mitigating the damage, and that's like 121 people and like a baby maybe, and half a person. So yeah, so basically that's so your coronavirus, and you used geometric series to find how many people were infected, and wow, like who said math wouldn't have real life applications? And so if you want to keep the numbers this low, if you want the rate of increase to be less than 1 and to converge instead of being greater than 1 and to keep going up and up like we saw in like the first few days, but please maintain your social distance, wash your hands whenever you need to, don't touch your face, and stay safe out there. Just take general precautions and listen to what the CDC is telling you. And yeah, so stay safe out there. Thank you for learning some math with me as I'm stuck in my room because of the coronavirus. And thank you for watching. Have a nice day.